Also, like I said, 7.2 deals with transformations of graphs. So basically, we're going to look at six basic graphs, and we're going to see how you can move them up, down, left, right, and reflect them, okay? So first of all, we're going to draw the six basic graphs. Okay, so we'll be drawing six of these. So y'all, let me get one more in here. All right, y'all. So the first basic graph is a line graph. This will be the graph of y equals x. So this is your basic line graph, and it sort of goes right through the origin and makes a straight line. So y equals x is our line graph. So the second basic graph, this is going to be the y equals x squared graph. You all remember the x squared graphs are the parabolas we've been drawing. And they sort of make the U shape, touching in the origin, okay? Next, we got the cubes. So the cube graphs for the y equals x to the cube, these graphs sort of come up, go through the center, and then go uphill. So like one cubed, two cubed, and so on. And then negative numbers, when you cube them, they stay negative, okay? All right, y'all, so there's three more basic graphs. This will be the square root graph. Y equals the square root of x. Now this graph starts on the right side in the origin and just sort of slowly goes uphill to the right. So like one squared would be one, two squared would be, the square root of one would be one, square root of four is two. So it don't go real fast uphill to the right. Now it's not on the left side of the y-axis because we cannot take square roots of negative numbers, okay? All right, the next graph is the cube root. So similar to the x squared graph, the cube roots, but they will grow even slower than the square roots. But y'all, the cube roots can go in the negative direction. Because you can take the cube root of a -8 and get a -2 and so on, okay? So square roots, we can't be negative, but in the cube roots, you can be on the negative side. All right, y'all, the last graph, that's a basic graph that we're going to worry about. Is the y equals 1 over x. We often call this the reciprocal, because if x is 1, y would be 1, but if x is 2, y would be 1/2, and so on. But y'all, these graphs on the left side, they come down. And then on the right side, it comes down and tries to hug the x-axis. Now, this graph cannot cross over the y-axis because that's where the x value is 0. And if we had a zero in here, that would make it undefined. So that graph cannot cross over where x is zero, okay, because of that fraction. Now, we don't have to know much about these graphs other than that these are the basic shapes. And these are the shapes we're going to be moving around in a little bit, okay? So there's three transformations we're going to be looking at. So I'm about to list them for us. All right, y'all. So the first transformation we're going to do to these graphs is what we call a vertical shift. And vertical shift is either up or down. Okay. So how do I move these graphs up and down? I'll have this type of equation. Y equals f of x plus or minus b. So they take the function and add or subtract a number to it. So f of x would actually be the basic function, okay? So if I put an x squared here, this would be x squared plus or minus some number. So here's the thing. If this b is positive, that will move the graph up b units. Well, if that's plus 5, it's going to move me up 5 units, okay? Now, if that b is negative, well, if you're subtracting the number from the function, it's going to move it down b units. Okay, so they're just taking the function, which we got 6 of up here, and they're adding or subtracting from it, okay? That's going to move me up or down. The second transformation is going to go left to right. That is a horizontal shift. So that's going to be left or right. All right, so to go left to right, you'll have y equals f of x plus or minus a. Now, y'all look at the difference. Up here, the function is not affected, and we're just adding or subtracting a number. For horizontal shifts, the adding or subtracting will be done inside parentheses with the function, okay? So if it's inside the parentheses, it's going to be horizontal. If it's at the end, it'll be vertical. Now, horizontal is a little bit backwards from what you would think. If A is positive, so if I'm adding to the X value before it gets evaluated, that's actually going to move my graph to the left. A units. Okay, so adding does not move me right like you would think. It actually moves me left. And then if A is negative, it's actually going to move it right A units. And the reason is because we're actually changing the X values before they get evaluated, okay? All right, so we had one more transformation we'll look at. And this is a reflection over the x-axis. All right, so we're only going to reflect over the x-axis at this point, and to do that, you would have a negative f of x. So what it's doing is it's taking all your values, multiplying by negative. So if they were up here in positive, it's going to flip them down and make them negative because of that negative, okay? All right, y'all. So what we're going to do, let me pull MathLab up for a second while y'all copy those. And I'll actually show you how to do these in MathLab, okay? All right, y'all. So the main thing is to remember what these basic graphs look like. Okay, so have a copy of that handy when you do these kind of problems. Okay. All right, so we're going to pull these up in MathLab so y'all can see how to graph them and do everything. So let me share MathLab. All right, y'all, so let me show you how we're doing this one. It says, describe how the given function can be obtained from one of the basic graphs. Then we're going to graph the function. So we got y equals x minus 4 squared. So I see that exponent of a 2 out there. That's letting me know that I'm starting with the x squared graph, okay? Now, what we got to figure out, they're subtracting 4 from the x inside those parentheses. So, y'all, what did we say we would be doing if we subtracted from our variable inside the parentheses? And y'all, that would have been our second transformation, which was horizontal. And remember, we said if we subtract a number from the x, it's actually going to move it to the right. So we need to come down and pick the one that says they went right 4 units, which would be D. So you highlight that. And then where it says start with the graph of, that would be x squared. So we would put in our x and then square it. Okay, y'all? So now you're going to check that answer. And it's going to want us to graph it. So at this point, we click on enlarge graph. Now this is going to do all the moving to us. So what we got to do is pick out which one of these looks like the x squared graph. And that's going to be your U-shaped quadratic tool. You're going to click on that and then click anywhere on the graph. No matter where you click on the graph, it's going to start it out looking like our basic graph. Now you see it popped up a little window here. Now don't worry about the top two things that say vertical stretch and horizontal stretch. We're not doing that. All we're worried about is the stuff that says vertical shift, horizontal shift, and reflect over the x-axis. So we said that was going to shift my graph 4 units to the right. So that's a horizontal shift. So you're going to come down here and drag that little tab right until you get to 4. Now look at my graph. It moved it right 4 units up there. So at that point, you're going to save it and then check your answer. All right, y'all, let's look at this number 2. So this is g of x equals x minus 10. Well, the x would be my basic graph for the line graph, the very first one we had where we said y equals x. So we know the basic graph is x, but they're subtracting 10 from the end of it. not in parentheses. So y'all, on that one, by subtracting 10, what's it doing to my graph? It's either going to, well, shrinking it. Like I said, we won't do no shrinking, so ignore that one. But is it going to go up 10 units, left 10 units, or down 10 units? Well, y'all, we said when the numbers were being added and subtracted at the end, it was either going up or down. That what you got down? Perfect, because when we subtract, it does go down. So we would choose D, and then the basic graph would be the y equals x. Now this one, when you graph it, you physically have to pick 2 points on it, okay? To draw the line. So I'm going to grab the line tool, and we physically have to find 2 points. So if I let x equals 0 and I plug it into that, I get 0 minus 10, which gives me negative 10. So I'm going to have 0, negative 10 as my first point. And then let's say, what if I make x equal 10? If x is 10, 10 minus 10 gives me 0 for the y. So that one would be over here at 10, 0. So y'all, on number 2, for the line, you actually got to plot 2 points. But look at it. It was going through the center as a basic graph, and now it's went down 10 units, okay? So number 2, when it's the line graph, is the only one you got to graph using points. All right, y'all, now this one, h of x equals 1 over x plus 5. The 5 is at the end of the function. So what would y'all go with? 5 units left, 5 units up, 5 units down, or 5 units to the right. Now remember that 5 is not inside parentheses with the x. So it's either going to go up or down. And since we're adding, it will go up. Good job. All right, so we would check that answer. Now, y'all, this one gives you 4 pictures. What we want to know is which one of these graphs went up. Looks like A is my basic graph we drew a while ago. So A is the basic graph. So did B or C go up? Well, y'all, let's see. Looks like B went down, right? B, everything shifted down. And if you look at C, everything shifted up. So we would pick C on that one and move on, okay? All right, y'all, negative x plus 7 in parentheses to the third. So we've got the cubic graph, the one that sort of went uphill left to right, okay? So that's our basic graph, x to the third. But let's see, that x plus 7 is inside parentheses. So that's either going left or right. So since the 7 is being added to the x and it's positive, it's going to go left. So now you got that left. And then remember, that negative in the front is going to reflect us over the x-axis. So do not choose anything that has y-axis on it. So it's either going to be A or D. Y'all said I'm going to move left. So let's see. That has to be A. And then remember, we're going to start with our graph of x to the third. So we'll shift it left 7 and then reflect across the x-axis. Also, we're going to click the enlarge graph. Remember, the cube graph was the x cube tool. So y'all, now you're just going to click it click anywhere on the graph, it's going to throw it right in the center. So what did we say? We went left 7. So the horizontal, we're going to move to -7 since it went left. So see it move my graph left. Now y'all watch this. It was going uphill, but we're going to come down and click the box that says reflect over the x-axis and watch my graph. Instead of going uphill, it now goes downhill. So you would save that and then check your answer. You know, these aren't bad. You just got to get used to what's the basic graphs on these, okay? So y'all, let's see what we got here. Well, we know the basic graph. We see that exponent of 2. So our basic graph will be the x squared. But y'all look here, it says shift it blank 1 unit. Y'all see that 1 is inside the parentheses being added to the x? So is that 1 going to shift me left, up, down, or right? So it's going to be left, good job, because it's inside the parentheses being added. And then it says shift it blank 2 units. Well, that 2 at the end is being added. So that's either going to be right, left, up, or down. And let's see what y'all got. Up on that, good job, y'all. So that's what you got to watch out for. Are those numbers inside parentheses or are they on the outside? All right, so this one had 2 moves. So we check our answer. Click to enlarge the graph. We had the x squared graph, so that's the U-shaped parabola. We went left 1 unit, so that'll be horizontal to -1. And then what do we do? Up 2, so that'll be vertical over to +2. So y'all look at that. It moves it left and up. You're going to save that graph and then check your answer. So y'all, here's an interesting one. When the number is being added to the x and it's inside of that radical like that, we treat it like it's in parentheses. Okay, so let me show y'all real quick on the radicals. So if you had something like f of x equals square root of, say, x plus 2, since it's under the radical, you would treat it like it's in parentheses, and that would actually move me left 2 units. Now, if you had it like this, f of x equals square root of x plus 2. Now, y'all notice the difference. This 2 was under the radical with the x. This 2 is on the outside. If it's on the outside of the radical, this one would move me up 2 units. Okay, so under radicals is treated like parentheses. Outside, just treated like adding or subtracting that number, okay? Which means radicals have the same priority as parentheses if you're doing order of operations, okay? All right, y'all, so that 5 is underneath the radical. So let's see. Is that going to shift me down, right, up, or left? Oh, y'all want to go down to left. There you go. And it's going to shift it left. What do we say? 5 units. Okay. So now, let me make these just a little bigger maybe. So A, B, C, or D, which one went left 5 units? As y'all remember, that's a square root graph, and the square root graph usually starts right in the origin there. So it looks like A went right. Let's see, y'all are saying B. Yeah, it looks like B's starting left now. C looks like it went down and D went up. So we're going to go with B on that one. All right, y'all, let's see if y'all remember what I just said about radicals. You got a cube root of x minus 6. They're telling you you're starting with a cube root of x as your basic graph. So that minus 6, is it going to shift me left 6, down 6, right 6, or up 6? And let's see, what are y'all saying? Oh, I got an up and a down. Now, y'all remember, the numbers at the end actually do what you think they will do with the adding and subtracting. So remember, if it's at the end like that -6, that's actually going to move me down 6. Okay. So that would actually be 6 units down. So Jackson, the only ones you really got to worry about being backwards is that horizontal. Okay. They're backwards based on the signs, but the vertical, if it's adding is going to go up, subtracting is going to go down. All righty, y'all. So who went down? A, B, or C? Now we'll say B is the basic graph that you start with. So it's either going to be A or C that went down. And y'all look here. It definitely looks like A, right? That whole graph went down 6 units. It looks like C, everything went up, okay? So then we would do our final check. And next question. Oh, now this is the last one, and we don't even have to graph this one. We just got to figure out what it's doing. So y'all look at that. We got a negative x minus 7 in parentheses squared plus 6. So they're starting with the 7 inside those parentheses. Since that 7 is being subtracted, are you going to go left 6, left 7, right 6, or right 7? So that says what, right? So good job. Since that 7 is negative, it's actually going to move it right 7. Then you're going to reflect it across the what? The x-axis. Good job. And then that plus 6 at the end, we're going to go up 6, down 6, down 7, up 7. Oh, so I'm getting an up, so we're going to go up 6 on that one, okay? So they just sort of almost follow order of operations, right? They did the parentheses first, and then they did the negative out front, and then they did that number at the end. But y'all, we checked the answer and we're done. Okay. So that's transformations. You want to know them 6 basic graphs that we drew, because those are basically the ones you're moving up and down, okay? So y'all, let's get into this one. 7.4 quadratic equations. All righty, so I will say this. On the first one, we're going to solve that by factoring. But the rest of these are not going to be able to be factored, so we're going to find other ways to solve them, okay? Now, I will say, um, the three ways to solve quadratic equations. So the first way is solve by factoring. Second way we'll mess with a little bit later is solve by taking square roots. So I'll solve by taking square roots if I got an x squared on one side and a number on the other. But the big one we're going to learn about today is solve by quadratic formula. Okay. So if you cannot factor, the one guaranteed method that will solve every single quadratic equation is the quadratic formula, okay? Now, like I said, if it don't have the x term and it's just the x squared and a number, I use the square roots. We really don't have many of them today. And in factoring, always look to see if they factor, because that's easier than the quadratic formula. But y'all, if they don't factor, we got no choice but to use that quadratic formula, okay? Now we use different terminology in here. We use terminology such as zero. Zeros are just the solutions to quadratic equations. And really the reason we call them zeros is because to solve a quadratic equation, we set it equal to zero, okay? Y'all, so what we're going to do now, we're going to play with some of these. So what these examples will say, now we'll do the first one, like I said, by factoring. And then we're going to have to learn this quadratic formula to do the rest. Okay. So this one will say, find the zeros. And they put S in parentheses because it could be one zero or many zeros of the following function. Now I'll tell y'all a little trick on these. The highest exponent of your equation will tell you how many zeros you got. So since we're messing with quadratic equations, which are x squared, remember these are x squared equations. That means we have two solutions to these, okay? So y'all, the first one they're giving us, f of c equals c squared plus 6c plus 8. They're giving us an equation. So since we want to solve this, we're going to take this equation, c squared plus 6c plus 8, and we're going to set it equal to 0. Now, like I said, this one will factor. Okay? So let me ask y'all, are y'all decent at factoring, or are we going to need us a factoring review? All right, so I'm assuming everybody can factor this. Uh-oh, let me see. Macy, what's that say? We'll do a review. Let me just give y'all a basic review on factoring then, okay? So we'll call this our factor review. Now, I ain't gonna lie, y'all. I factor big. I look at the signs on these things, okay? So you basically got an x squared plus a bx plus c, okay? Now, this can be plus or minus. That can be plus or minus. But when we factor, we always want to find factors of the last number that'll equal the middle number. So here's the thing I look at first. If this last sign is positive, then both factors will have the same sign as the middle number. If this last number is positive, that means both of your factors, when you write them out, they will have the same sign as the middle number, okay? So let's look at a few cases of that. What if I had x squared plus 10x plus 24? Well, the last one's positive here, right? That 24 is positive. Now the x squared would be an x and an x. So that 24 is positive. We just said both factors will have the same sign as the middle. Well, the middle's positive. That means both of these factors will be positive. Now the second thing, find factors of last number that add to get the middle number. So all I need to do is find factors of 24 that'll add to get 10. So y'all, you can write out your factors. You got 1 times 24, 2 times 12, 3 times 8, 4 times 6. What two factors do I want out of this list that'll give me a 10? And that's going to be 6 and 4, y'all. So I can put in my 6 and 4. Notice 6 plus 4 equals 10. 6 times 4 equals 24. So that one's done. Now y'all try this one. X squared minus 14x plus 24. Y'all, the x squared is still an x and an x. This last number's positive. So both of my factors will have the same sign as the middle number. So they're both going to be negative. So the only way to get two negatives on this is if it's negative in the middle and positive at the end. Now I got the factors of 24 up here. So what factors of 24 will equal 14? Uh, 12 and 2. Good job. Now look, it don't matter where I put my numbers because they're both negative. Didn't matter where I put the 6 and 4 up here because they were both positive, okay? All right, y'all, so these two are factored. That's what you do when the last number's positive. But what if I got a last number that's negative? Well, y'all, how can you multiply and get a negative in math? That means You got to have unlike signs, right? So if the last number is negative, factors have unlike signs. So I'm automatically going to make one plus and one minus. Okay. Now, I don't know if y'all remember the rules for adding unlike signs, but when we add unlike signs, we subtract the numbers and give the answer the sign of the larger number. So when it's negative, I'm going to find factors of C that subtract to get B. Now, the larger of the two factors has the same sign as RB. Okay, so they got unlike signs. You find your factors that'll subtract to get the middle number, and the larger factor will have the same sign as the middle. So y'all watch this. I got an x squared plus 7x minus 30. So I'm going to make my parentheses. X squared is an x and an x. That last number is negative, so we're automatically going to make a plus and a minus. So y'all, let's find factors of 30. That'll be 1 times 30, 2 times 15, 3 times 10. Let's see, 4 don't work, and then we got what, 5 times 6. Two of these numbers will subtract and give me a 7 since that's minus. What you got, Nat? 10 and 3, perfect. 10 and 3 equals 7 when you subtract. But then remember we said what else? The larger factor has the same sign as B. So since B is positive, 10 will be your positive factor and 3 will be your negative factor. Y'all look at this. 10 minus 3 equals 7. 10 times negative 3 equals negative 30. All right, y'all, let me see what I'm on here. How about x squared minus x minus 30? So we got an x squared, that's an x and an x. Y'all, that 30 is still negative. Since that's negative, one factor is positive, one's negative. There's not a 1 in front of that x or a number, so we're going to treat it like a 1. So we need factors that subtracted to get 1, and that you got 5 and 6, perfect. And all we got to remember is, because 6 minus 5 is 1 like we got here, but remember the larger factor will be negative like the middle. So y'all, 6 is larger. 6 has to be negative and the 5 positive. Because now negative 6 and 5 equal negative 1. 5 times negative 6 is negative 30. So y'all, that's the stuff I follow when I factor, okay? I look at them signs to get me a little bit of a head start on them, okay? So knowing that, we're coming back over here. C squared, we know, is a C and a C. So the question of the day, what's going in these parentheses? Pluses, minuses, and what numbers? What factors of 8 will give me a 6? What am I getting? C plus 2, C plus 4, perfect. They're both positive because remember this is positive. They're both positive like the middle. And then my factors of 8 that equaled 6 were 2 and 4. So now remember, we're solving this by factoring. So we've got it factored here. So now to finish solving it, you take each factor and set them equal to 0. Okay, because remember, the zero product rule says if this factor equals 0, the whole answer would be 0. If we can get this factor to equal 0, the whole thing would equal 0. So y'all solving these, we're just going to what? Subtract 2 from the first one. So C is a -2, and then subtract 4 on the second one, and C is a -4. So notice the zeros always have an opposite sign than the factors, okay? So remember that. Zeros always have an opposite sign than the factors. Now, y'all, what we're going to do real quick is getting near break time. We're going to look at what we call a quadratic formula real quick, okay? So, when a quadratic equation does not factor, we use the quadratic formula okay? So the quadratic formula says if ax squared plus bx plus c equals 0, then the solutions are given by x equals, all right, so this is the fun one y'all learned in school. X will equal -b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2a. Okay? Now, the way it gives you the two solutions is by that square root being plus or minus. Because remember, y'all recall this. What's the square root of 9 equal? So y'all, what is the square root of 9? Well, I thought I was hearing something on my thing, but I didn't hear nothing good. All right, Chase, you got one of the square roots of 9. 3 is the right answer. But y'all, there's another square root of 9. What else times itself will give me a positive 9? So y'all, how about a -3? -3 times -3 is 9, right? 3 times 3 is 9. So you learned that the principal square roots of these numbers were positive. But remember, 2 negatives will make a positive. That's why they got a plus or minus here. Because we add the positive square root first to get the answer. And then, since we know 2 negatives make this, we take the negative of the square root for the second answer. Okay, that's how we get the two answers. -b plus square root of all this over 2a, or -b minus all of this over 2a. Now, y'all, since that's a fraction, the only stipulation we have on this A cannot equal 0 on that, okay? Which means you got to have the x squared term in order for this to work. So y'all, here's your quadratic formula. We're about to take our break, and when we come back, we're going to start working this boy, okay? There's like 4 or 5 questions we're going to play with that on, okay? So it is 10:52, so we'll take a break till 11:02, okay? And I'll see y'all in 10 minutes. All right, y'all. So let's continue on. So I'm going to get us recording again. And we're going to start working examples using our quadratic formula. All right, y'all. In these examples, we'll say the same thing. They'll say find the zeros. And they're giving me f of x equals x squared minus 2x minus 4. Now, if I was going to try to factor it, I'd have to find factors of 4 that subtract to get 2. Well, y'all, the only factors of 4 are 4 and 1, which subtract to get me 3, and 2 times 2, which subtract to give me 0. So there's no way to factor this 4 to get me a 2 in the middle. So we're going to set it equal to 0. And we're going to use the quadratic formula. So first of all, we got to find A, B, and C. Well, A is always the number in front of the x squared term. So since there's no number there, A is automatically 1. B is always the number in front of the x term. So that's going to be negative 2. And then C, the last number, is a negative 4. All right, so let me write our formula back up here. X equals negative B plus or minus square root b squared minus 4ac all over 2a. Hey, also, here we go. We're going to start plugging in. So that negative is in that formula. So you're going to write that negative first. Then you're going to put in your b, which is a negative 2, plus or minus square root. So really this negative right here, its only purpose is to change the sign of whatever that b was. Okay. All right, now we got b squared, which is negative 2 squared minus 4 times a, which is 1, and c, which is negative 4. All of that's over 2 times a, which is 1. So y'all, it's now just a matter of starting to simplify this. So this negative times negative makes that a positive 2 plus or minus square root. Negative 2 times negative 2 is a positive 4. Now, everything on this side over here, minus 4 times 1 times negative 4, all of this is being multiplied. So we got a negative 4 times 1, which is negative 4, times negative 4, which gives us a positive 16 all over 2 times 1, which is 2. All right, y'all. So here we go. Bring down your 2 plus or minus. 4 plus 16 gives me a square root of 20. All of that over 2. So y'all, my next question. I played with y'all on the factoring a while ago. Are y'all able to simplify these square roots, or do we need a little review on that? All right, y'all. So what I'm going to do, I'll simplify this. Let me give y'all just a little quick review, real quick, on radical review. And this is basically on square roots. So over here, I'm going to write perfect squares. Perfect squares are numbers you get multiplying the same number times itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. What's next? 9 times 9 is 81, 10 times 10 is 100. Um, that's probably big enough, but we could keep going on, okay? So here's the thing. To simplify a radical, we must remove all factors that are perfect squares. Well, our perfect squares are sitting over here. So y'all, let me show you what I'm talking about. What if I had something like the square root of 40? So here's my 40. Now, the only factors I'm worried about are these perfect squares. But are any of these perfect squares factors of 40? And we definitely have one. Oh, Raven, look at these. Do any of these numbers multiply to get me a 40? 4, perfect. Because y'all, 4 is a perfect square. So since 4 is a factor of 40, I would write this as a 4 times 10. Now, the reason we did that, we can now take the square root of 4. Square root of 4 is 2. So this simplifies to a 2 times square root of 10. So y'all look at that. 10 does not have any more factors that are perfect squares, because really 1 don't help you, because that'd still be 1 times 10, right? So 1 don't help us. So we're looking for 4, 9, 16, and so on. But y'all, none of those are factors of 10, so that is your final answer. Okay? So knowing that, let's go back to our problem. So on the side, we're going to simplify that square root of 20. Well, what perfect square would be a factor of 20 out of that list we just did? So I think you got the final answer in that. So to get that, she made that a square root of 4 times the square root of 5, because you need numbers that you can take square roots of. Okay? So the square root of 4 is 2. So that'll give you a 2 square root of 5. Okay? There you go. So that's the trick on that. So now I know what my radical simplifies to. So this is going to give me 2 plus or minus 2 square root of 5 over 2. Now, the final step is to take the outside numbers and see if they divide by the bottom number. Because remember, both of these on top are both affected by that 2 on the bottom. So we got 2 divided by 2, which will give me a 1 plus or minus. And then here the 2 divided by 2 cancels, making a 1. So we got 1 square root of 5, or we could write that as a square root of 5. Now remember, if there's not a number in front of that radical, we know it's a 1. So y'all, now, MathLab will let you write this as one answer like that using the plus or minus. But what really this is telling me is that my first answer is 1 plus square root of 5. And my second answer technically is 1 minus square root of 5. Okay? So that's how you get the 2 answers, is by using that plus or minus. Hey, y'all, so that's what we're doing. We're playing with the square quadratic formula. And I say the trickiest part is simplifying them radicals if you got to, okay? So let's look at the next one. They're giving me f of x equals 3x squared minus the x plus 4. I'm going to set this equal to 0. 3x squared minus x plus 4 equals 0. I'm now going to get my numbers for a, which is 3. B is a -1. Since there's not a number, it's a -1. And then C will be 4. All right, now let's plug this into our formula. X equals negative B, which is -1, plus or minus square root -1 squared minus 4 times A, which is 3, C, which is 4. All of that over 2 times 3. So get your numbers plugged in, and then we start simplifying. Negative times a -1 makes that a +1, plus or minus. And then we got a radical. -1 times -1 is a +1. And y'all, no matter what you got here, when you square it, it will be positive, okay? Now y'all look at this side. All that's being multiplied. -4 times 3 is -12. -12 times 4 is a -48. So if there's just one negative over here, it will stay negative. And y'all, all that's over 2 times 3, which was 6. All righty. Continuing under the radical, I get 1 plus or minus square root. 1 minus 48 is a -47 all over 6. All right, y'all, so here's the thing on the side. I got a square root -47. Well, in the real world, we cannot take square roots of negative numbers. Because there's not, when you multiply like signs, there's no way to get a negative. So this is where we get imaginary numbers from. So they said, well, we're going to let I equal the square root of -1. So it's like pi. When you see pi equals 3.14, blah, blah, blah. When you see an I, it equals the square root of -1. So There's no perfect square factors in 47, but I got to take care of that negative. So what we do, we break that negative out as a -1. Now, although we can't take the square root of -1, we bring it out as I. So that's going to give us the I, and then our square root of 47. Okay? So, nothing else I can do that because 47 didn't have no factors that were 4, 9, 16, and so on. So this becomes a 1 plus or minus I square root of 47 over 6. Now, here's the thing about this one. Since we got an imaginary answer here, we got to split this into a real fraction and then the imaginary fraction. So we're writing it what we call as a complex number. Okay, we split this apart. Well, if we split this apart, we get 1 over 6 plus or minus I square root of 47 over 6. So in MATLAB, you gotta punch it in this form right here. That looks like the real number and then the imaginary number, okay? So when they say, what are they saying? Express complex numbers in terms of I, that's what they're talking about right here, okay? They don't want to leave negatives under the radicals. They want y'all to write them out as complex numbers. And then, so you could use the plus or minus to write it one time, or you could do 1 over 6 plus I square root of 47 over 6, comma, 1 over 6 minus I squared of 47 over 6. But like I said, MATLAB has that plus or minus, and that's probably the easiest way to do them, okay? Oh, y'all, let me see what they're doing on this next one. So this one, they're giving us f of x equals 5x squared minus 7x minus 3. Now, they want exact answers and approximations. Now, on the approximations, they want me to go out 3 decimal places. Okay, so I use my calculator for the approximations. Exact answers means with the radicals, okay? Approximations is with decimals. So let's set that equal to 0. 5x squared minus 7x minus 3. A is 5. B is -7. C is -3. So let's plug it in. X equals negative times B, which is -7, plus or minus square root -7 squared minus 4 times A, which is 5, and C, which is -3. All of that over 2 times A, which is 5. All right, y'all, so here we go. Negative times negative makes that a +7, plus or minus. Let's see what's under my radical. -7 squared is 49. Once again, everything over here is being multiplied. So -4 times 5 is -20, times -3 is a +60. All over 2 times 5, which is 10. All right, so notice the only thing I can do is add the stuff under the radical. So 7 plus or minus square root. 49 plus 60 is, what's that, 109 over 10. So on the side, we're going to play with that square root of 109. So y'all, are any of my perfect squares factors of 109? So let's see, that's not dividing by 4. It's not dividing by 9. It's not dividing by 16. It's not dividing by 25. It's not dividing by 36. That won't divide by 49. And y'all, everything else is pretty much getting too big. So this does not simplify. So since that radical does not simplify, this is my final answer. This is my exact solution. Now, we're going to do our decimal approximations. Now, we got to do this twice on the calculator. First of all, we're going to do the plus, and then second, we'll get the second answer doing subtraction. So I'm going to share my calculator and show you how I figure them out. So the first thing, I'm going to get the big fraction by hitting alpha y equals and enter. So let's see, on top I had 7 plus square root, which will be second x squared. Under that I had a 109. Then I'm going to arrow to the bottom and I had 10. All right, y'all, there's my first one. When we hit enter, we'll get the first decimal approximation. So they want 3 decimal places. So that'll be 1.744. So the third decimal place was a 4. I looked at the next number to determine whether I kept that a 4 or I rounded it up. Since that was a 0, I kept that a 4. Now to get the second one, I'm going to do the fraction again. Alpha y equals enter. On top of this one, we got 7 minus square root of 109. Arrow to the bottom, put in our 10. And when we hit enter, we'll have the other decimal approximation, which is a negative 0 point, what's that, 344. Once again, it's got a 0 after the last 4. So I keep that a 0.344 negative. All right, so on that one, it'll ask you for the exact solution, and then you'll come in and put your decimal approximations, and I believe you just put a comma and then the next one, okay? All right, so that's a tricky one because you had to do the decimals on it. All right, y'all, so one more of these, and then I'll show y'all a little bit of the next section. So this one, I got f of x equals 3x squared minus 7x minus 5. So I'm going to set that equal to 0 again. I'm going to get my A, B, and C. 3, negative 7, and negative 5. Well, this one looks like this one, except they reversed the 3 and the 5 on it. Oh, well. All right, y'all, here we go. X equals negative B, which is negative 7, plus or minus square root, negative 7 squared, minus 4 times 3 times negative 5 all over 2 times 3. Now, y'all often get asked about the 4 and the 2. That 4 and 2 are always in the formula, okay? All we do is put in for our B, B, A's, and our C. All right, y'all, so negative times negative makes that a positive 7, plus or minus. All right, so 7 times 7 is 49 again. All this is being multiplied. So negative 4 times 3 is negative 12. Times negative 5 is a positive 60. Oh, this is really close to the one I just did. And 2 times 3 is 6. All right, y'all, so let's add that. So this will give me 7 plus or minus square root 109 all over 6. And y'all, we already know we can't do that 109 because we did that 109 up here. So we know 109 is not going to simplify. So that is our final answer. So y'all really, you gotta watch out for working that radical under this radical being able to simplify if needed. If these numbers don't have those factors in them, you leave it there and be done, okay? So y'all remember that one from school, right? That quadratic formula. Someone was telling me y'all used to sing songs about it to remember it. So, all right, y'all, hang on 1 second. I'm gonna pull up something for my oh, they're gonna make me re-log in. Oh, I hate doing that. Okay, here we go. All right, hang up 1 second. I'm gonna pull up 4.8. It only has 4 questions. Um, all right, the first 2 ain't bad. The last 2, whoo, maybe a little bad, okay? So this is section 4.8, applications of polynomial equations. All right, y'all, so you're looking at this graph right here. What I want to know is, what are the x-intercepts of this graph? And there's 2 x-intercepts, they got them blue dots on. So what I need to know is, this first x-intercept on the left, what is it? And notice it says type of ordered pair. So you're going to come up here and do parentheses for your ordered pair. So we just want to know what that point is. So since it went left -2, the x value is -2, comma, 0. Good job, Raven. And then we're going to close parentheses, comma, and we're going to start the next ordered pair. Well, y'all on the right side, what's the point on the right side? What is that as the ordered pair? Oh, Raven, switch them around for me. So get that 5 first, good job, and then 0 for your y. So y'all remember, x-intercepts always have the x value first and then the y. So y'all, you're going to check those. And then it wants to know the solutions. Well, y'all, here's the thing about this. The solutions, if you're looking at a graph of a parabola, the solutions are the x values of the x-intercept. So that means my solutions would be -2, comma, 5. If you were to factor that or use the quadratic formula, your two answers would be -2 and 5. Y'all, what they want y'all to realize is that graphing a parabola, you can find these solutions by looking at these x-intercepts, okay? So y'all watch this. We hit answer. So I'm gonna make this bigger. Y'all tell me, what are my x-intercepts? And they gotta be ordered pairs, okay? So I got -2, 0 is the first one. Good job. And then comma, and then how about my next one? Y'all are giving me 5, 0. Good job. Okay, so y'all just got to remember ordered pairs. So you basically got 3 commas on this in between the numbers and then in between each of these parentheses, okay? So knowing that, what are my solutions to this quadratic equation? -2 and 5. Good job. And then you check your answer. All right, y'all. So I'm about to play with y'all on this next one. There's only 2 more questions, but let's look at this one. Y'all look at this. Let me write this down as we're going. A wire is stretched from the ground to the top of an antenna tower. So the wire is 17 foot long. Didn't they say the height of the tower is 7 feet greater than the distance D from the tower's base to the end of the wire? So look what they want. They want to find the distance D and the height of the tower. So word problems are fun. So let's go in here and let's figure this one out. So first I'm going to draw a picture. So I've got this antenna tower over here. So this will be my tower. And I got a wire stretched from the ground to the top of my tower. So I've got a wire that they're stretching from the ground to the top of my antenna tower. Okay. Now, first thing I know, this wire is 17 feet long. Okay. Now, they did say over here, the height of my tower right here is 7 feet greater than the distance D from the tower's base to the end of the wire. Well, here's the base of the tower. Here's the end of the wire. So they're saying that little distance right there is D. So here's the question. If this is D, what can I use to represent the height of this tower based on what they're giving us up here? Because let's see, y'all, they said what? The height of that tower is 7 feet greater than the distance D. Well, y'all, if that's D, this has to be D plus 7. Okay? Now, what we hope y'all are realizing is this makes a right triangle. So it's a triangle. It's got a 90-degree angle on this corner. So that makes it a right triangle. So y'all should know a nice little formula that finds me the sides of a right triangle. So do y'all know what I could use to find the sides of a right triangle? And it's a theorem y'all should have learned at one point in time. Good job, Pythagorean theorem. Good job. We're going to use the Pythagorean theorem to solve this. So do you remember what it is? It is a squared plus b squared equals c squared. There you go. Now, y'all, here's the thing. C has to be the hypotenuse. So C is the hypotenuse, which is the longest side, okay? And it's always on the side of the opposite that 90-degree angle. Okay, y'all? So all we got to do is figure out who A, B, and C is. Well, that's the longest side. That has to be C no matter what. A and B can be either one of these. It don't matter. So I'll let D be A. B plus 7 equals B. All right, y'all. So let's go. I think Nat, you're on the right track. Good job. So I have my A, which is D squared, plus B, which is D plus 7 squared. That's going to equal C squared, which is our 17. All righty, so I can't do nothing with the D squared. I'm bringing that down. But y'all, D plus 7 squared, I'm going to work on the side. Because that does not equal D squared plus 49. Okay? When you got a D plus 7 squared, you got to write that twice. And you got to FOIL that. So D times D is D squared. D times 7 is 7D. 7 times D is 7D. And then 7 times 7 is 49. And then when you add those like terms, you get a D squared plus 14D plus 49. We can now replace D plus 7 squared with that. So D squared plus 14D plus 49. All right, so what is 17 squared? So let's see, 17 times 7 is what, 289. All right, y'all. So before I do anything, I'm going to add my like terms on the left side. So a D squared and a D squared will give you 2D squared plus 14D plus 49 equals 289. So this is quadratic because of that D squared term. So what do I need on the right side if it's quadratic? That 289 needs to be a 0. So to make that a 0, we're going to subtract 289 from both sides. So y'all, we still got our 2D squared plus 14D 49 and negative 289 is a negative what? 240. All this is now equal to 0. Now, y'all, I'm going to show y'all a trick. These are all pretty big numbers. But do you see a number everybody will divide by? Because as long as everybody can divide by a certain number, we can make this smaller. And all these will divide by 2. So I'm just going to make the equation smaller by dividing everybody by 2. Because as long as I do that to both sides, I'm good to go. So 2 divided by 2 makes that a d squared plus 14 divided by 2 makes it 7d minus 240 divided by 2 is 120 equal to 0 divided by 2 is 0. Now, y'all, here's the thing. All of these ones will factor. Now, the factors of 120 are hard to figure out in your head. So let me show you how I figure out the factors of 120. So first of all, I know d squared is a d and a d. Remember, the last number's negative, so one of these will be positive, one of those will be negative. So y'all, what I'm about to do is show you how to find factors of 120 on your calculator. Remember, we're looking for the factors that'll subtract and give us 7. Okay? So let me show you how I find factors on my calculator. So I go to y equals, and the number I'm looking for factors of is 120. So I put in 120, and then I divide that by x. So this will give me all the factors. If x is 1, x is 2, and so on. And all we're going to look at is the table. So we're going to hit second graph to pull up the table. And y'all ain't worried about them negative numbers right now. So notice, 0 is not a factor. But here are my factors. 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24. So I'm looking for something that has a difference of 7, so I need to keep going. 6 and 20, no. 7 is not a factor. 8 and 15, oh, y'all look at that. 8 and 15, if you subtract them, will get me a 7. So the factors I need are 8 and 15. So 8 and 15. Remember, the larger number 15 has to be positive like the middle. So the 15 will be positive, and the 8 will be negative. But y'all, now we've got it factored. Set each of our factors equal to 0 and solve. So here I subtract 15. I get d is a negative 15. Here if I add 8, I get d is a positive 8. So y'all, here's my question. How long is d? I've got 2 answers here, but I need to know which one y'all would pick for your distance d. It's 8, y'all, perfect. D has to be 8. If you get a negative number and you're dealing with distance, you throw it away. So I know the distance d equals 8. How about the height of my tower? How tall is my tower? And so y'all are getting 15, perfect, because d plus 7, 8 plus 7 is 15. So y'all, that's like your number 3. And we're going to do the last one. It's the same kind of problem, okay? A little bit different, but similar. All right, so hold on. Let's go back to Math Lab. I forgot we was doing it on Math Lab. Yeah, so on that we would put what do we get? 8 and 15. So 8 enter, and then come in and do your 15 and enter. All right, so next question. So y'all look at this, same thing. The foot of an extension ladder is 9 feet from a wall. So the foot of the ladder is 9 feet from the wall. Then they say the height that the ladder reaches on wall. So the height the ladder reaches on the wall and the length of the ladder are consecutive integers. Now, the only thing they want to know on this one, how long is that ladder? So they're only asking for one thing on this one. So y'all, guess what? I'm going to draw me a picture again. So what they're telling us, I got a wall over here. And we've got an extension ladder leaning up against it. Now, the only thing I know at the moment is the foot of my ladder right here is 9 feet from this wall. So this distance right here is 9 feet. Now, what else did they tell me? They said the height my ladder reaches on the wall here and the length of that ladder are consecutive integers. So y'all, I don't know this height right here. So what if I make that x? So if this is x and this are consecutive integers, what would I use to represent that ladder? What does it mean to be consecutive integers? So y'all, here's the thing. Integers are your numbers, your negative numbers, 0 and 1. So to be consecutive, they're talking about like 1 and 2, 2 and 3, 3 and 4. 2 integers in a row are consecutive integers. So how can I go from one integer to the next integer? Say if this is 5, what would you do to 5 to get the next consecutive integer? Add 1, perfect. So if this is x, this will be x plus 1, okay? Now, lingo they use in math, they might say consecutive even integers. Well, if it's consecutive even integers, you would add 2 to each number, okay? Oh, y'all look at that. I've got a triangle there, which means we're going to do a squared plus b squared equals c squared again. And once again, that's my hypotenuse. So that has to be c, and I'll let this be a, and that be b. So here we go, plug it in. 9 for a gives me 9 squared plus b, which is x squared. That's going to equal c, which is x plus 1 squared. All right, y'all. So 9 times 9, we know that's what? 81. Plus, can't do nothing with that x squared at the moment. But y'all, that is an x squared. So FOIL that out and tell me what I would put right here. So I'll give y'all a little bit of time to actually FOIL that out and tell me what I'm putting right there. Oh, that's quick. X squared plus 2x plus 1. Good job. So she did x plus 1 times x plus 1 and FOILed that out and gave me x squared plus 2x plus 1. Okay, y'all, so just take that on the side and FOIL it. Okay, so she FOILed that and got me that answer. So at the moment, it's quadratic with the x squareds. So we need to try to get everything on the same side equal to 0. But y'all, what's going to happen when I move this x squared by subtracting it from both sides? Y'all, look what happens here. These x squareds cancel, but these x squareds also cancel. The x squareds cancel out of both sides. So I'm left with 81 equals 2x plus 1. And y'all, I'll tell you the truth. At this point, the only difference between my problem and y'all's would be the 81. Y'all's x squareds will cancel just like mine did. And y'all are still going to have a 2x plus 1 here because it's going to get from that. So look here. It's not quadratic anymore. There's no x squared terms. So there's only 2 moves I need to do to solve for that x. So if y'all were solving for that x, let me see, Raven, let's see, you. All right, so you got the right number. So you must have come in and subtracted 1 from both sides, which gave me an 80 equals 2x. And then looks like Raven divided both sides by 2. So that we got 40 equals to my x. So Raven, the question of the day, how long is the ladder? Oh, what are y'all getting? 41? Perfect. So y'all remember, don't put 40 in math lab because that's this distance right here. Whoops, not that distance. That's my wall over here. But you got to add 1 to make that ladder 41. So that's where most people mess up. They'll put in the 40 without adding that 1 to it, okay? So let's go back. And in math lab, we're actually going to put the 41. And enter. All right, y'all, so I'm gonna stop my share. So I got a few announcements to do with y'all. Um, so that takes us up through 4-8. Now, tomorrow, Thursday, we will not have class. I've got a funeral to go to tomorrow for family. So we will not have class Thursday, but we will come in Friday and we got to do the vertex formula Friday and then square root stuff. So that's why my schedule is a little bit different than what I got in Math Lab now. We're not going to complete everything this week. I had a few days to play with. So um is there a link for test 1? You mean actually getting to it and doing the test? Um, so the link for test 1 is in your assignments. So let me go to let me share my screen here. So y'all I'm actually going to go on student view. So let me get this fixed how I need it. All right, y'all. So, Jackson, to get to test one, all the links are on your assignment page. And it'll be the one that says due over here on the side 6/9/24. You'll click on that test one, and then it'll let you start the test. Okay. Is that what you was asking for, Jackson? Okay, so here's the thing. Um, I sent y'all a, oh, okay, so where to put the homework link. Okay, so let me go back and show you that. So let me go back to Math Lab and let me go to my course content lecture videos, and that would be for week 2. So let me share this screen now. So y'all, the work that you're showing is only 5 problems that I got here. And you'll notice it says test 1 work. This is in week 2 of your course content lecture videos. And this is where you'll upload 5, 7, 10, 13, and 15. So what you do, you click that link and you'll create your submission. And if you want to write something here, you can. If not, that's cool. The main thing you got to do is upload file right here. When you upload files, um, what I would do is just do your work. I would just take a picture of it and save it as a file and upload that file, okay? Once you get that file in, you'll just hit submit and it'll tell you, okay? Alrighty. So yeah, I just picked 5 sort of mellow problems for y'all to send to work on. But yeah, just take pictures and ever how many pictures you need, you can upload them as a file and it'll get them to me, okay? Um, the reason y'all got to do that now is integrity of the online classes. Um, since we're not able to proctor everybody at one time taking the test, they came up with a way that if y'all show us work, that sort of takes care of that. So yeah, that's the thing on that. All right, y'all. So let's see. I'm gonna start downloading this into YouTube. When I get YouTube done, I will send y'all this link um, for these problems today. So remember, no class tomorrow. I will see y'all on Friday at 10 o'clock. So y'all, before I go, do y'all have any questions? Yeah, you can actually you had done the review, but if you've actually done the test, Kidron, then you can still send them in. I'll still take them. Okay. And all right, thank you, Raven, for that. And y'all, if I'm not seeing anything else here, so I will end our meeting and I will see y'all Friday at 10 o'clock. All right, let me see what my chat's saying real quick. All right, y'all. Thank y'all, and I'll see y'all Friday, okay?